So let's talk about this ASCII and Unicode encodings. First, let me discuss about the character encoding. So if you type a key on your keyboard, let's say ABCD, then the computer does not know what you typed because the computer only understands zeros and ones. So what they have did is they have created a mapping such that when you type a number will be printed on the screen, and according to that number the application considers that number as a character input. So okay, if that seems confusing, okay, let me show you. So these are the ASCII encodings or ASCII mappings. You can see the decimal here from 0 to 127. So ASCII is a 7-bit encoding. You can see the character. So if the decimal 0 means null. In the same way, let's go about these alphabets first, then you can easily understand everyone. So you can see decimal 65. If you see the decimal 65, it means character A. If you see decimal 66, it's B. So we will send this decimal in the binary, and the computer on seeing this, we will tell that the 66 is capital B. So when you type A, the application into the application, then the computer sends this 66 in binary, and then we consider this 66 as capital B and 65 as capital A. So that's how you just map some number to the alphabet, and you will send that number to the receiver side, and on the receiver side they will think that 65 is capital A. In the same way, up to this, there are also small lowercase alphabets. 97 means A, 98 means B, and so on. So in this way you can just represent 128 characters, 127 characters with this 7-bit value. Okay, 128 values using this 7-bit value. In the previous days, these are very helpful, and also these are enough. Like everyone uses English, and everyone 0, 1, 2, 3, 4 is numbers, alphabets, and some special characters, and these new lines, null values, and this acknowledgement, horizontal tab, backspace, etc. These are more than enough in the olden days. But whenever there is web developed websites have been starting, they have faced this whole ASCII as an issue, because everyone want to include their language in the applications. Like if you want to send your message, you want to send only this with these characters. So with these characters you can only include the English, but there are so many languages out there as well, like Arabic, Egypt, Chinese, Japanese, so many, and they have their own character set, they have their own alphabets, they have their own symbols, extra symbols. So how to include this? And after this ASCII, they have this extended ASCII codes for only main values, main symbols. This is called ANSI. So ANSI did not came out like officially, but they have just extended this 127 to 255. They have added another 128 special characters. So even though these mathematical symbols or any other symbols did not come helpful, because everyone wants their own language, right? Japanese want their own Japanese, because even though if you did not include, it will become very problem. The Chinese people want to send a letter to the Chinese, send a message, then it should be in Chinese, right? They can't convert English to Chinese, or everyone does not know English. That's why this Unicode came into play. What they did is, Unicode, they have already added these ASCII first 128 or 256 bits into their first 256 characters, and then they have added the other languages as well. So UTF comprises character encoding that can be compact as ASCII. So it is included ASCII, but this Unicode includes the 1 to 4 byte encodings. So if the character size is, suppose say A, its decimal value is 65. So in binary it requires maximum 7 bits. That's why Unicode will encode this A in 1 byte, and if the binary digits or length increases, then Unicode adds the another byte. So Unicode, especially UTF-8, is very famous in the web, and UTF-8 is variable length encoding. So according to particular character we want to encoding, this Unicode defines those in the many number of bytes. You can see for any character equal to or below 127 or 7f, the UTF-8 representation is 1 byte. So these are all ASCII characters, and these can be represented using 1 byte. Any character can be represented using 1 byte, and it is just lowest 7 bits of full Unicode value. This is also same as the ASCII value. So they have copied this ASCII and they have extended some more. For the characters equal to or below 2047 hex 07ff, the UTF representation is 2 bytes, and equal to greater than 2048, and then it is 3 bytes, and furthermore it is 4 bytes, as you can see. But there is some starting magic number, or like there are starting bits which are reserved to identify that these bytes are Unicode format, because if you can see, if you say all ones, then it can take this 127 as an ASCII character, so that will be wrong, right? So first byte, there is only 8 bits, so we can, these are the ASCII, and the first one is always 0. So number of free bits is 7. 2 power 7, it's 128, right? We can represent 0 to 127. Fine. So if there are 2 bytes, then the first bytes 3 places are filled with 110, and the second bytes first 2 places are filled with 10, and you can only use this x, and you can replace the bits with only these places with x. So number of free bits 7, you can just generate 2 power 11. I mean 2 power 11 minus 1 from 0. Alright, in the same way, if there are 3 bytes encoding, and the first 4 bytes are encoded are filled with 1110, and the second bytes with 10, and third byte is also 10, and the free bits are 2 power 16, and you get the maximum 2 power 16 minus 1. In the same way, if you have 4 bytes, and these 410, and then these 3 bytes, and in the same way second byte, third byte, fourth byte, these are all same, and you get the 2 power 21 minus 1. So with UTF-8 you can encode maximum of these, and there are also UTF-16 and UTF-32 as well. And this, you can see UTF test page. I'm going to this website. Okay, these are the characters. If you want to get the value of A, you need to say 0x4001. You want to say B, 0x4002. And I want to tell you one Unicode. Okay, let's open Telugu. That's my mother tongue. Okay, these are some symbols, and if you want to get the value of this one, you need to say C005. If you want to say value of this one, E, and if you want to specify 0xC008. So if you can also right click and open in new tab, you can see 0C05. So if you tell Unicode plus 0C05, you will get this Telugu letter A. So that's how these Unicode works. Okay, let's move on to some important topic again. Another one. This UTF-8 is mostly used in the web pages. Okay, that's fine. But if you are doing Windows buffer overflows, these Windows systems uses UTF-16. The main problem comes when you are sending some buffer into the applications. You will send A's, right? A's or B's or some other normal value. So these A's are 1 byte value, right? These A's can be represented in 7 bits. But this UTF-16, what it does is, it will encode everything as 2 bytes, minimum 2 bytes. So your 65 gets into 8 zeros, that is first byte, and then in the second byte it will encode the actual 65 value. So there is one actual null byte is placing in the value of A. So your A becomes 0000000 and then the 65 binary value. And for also B, it will add one null byte in front of this actual value, because UTF-16 encodes minimum 2 bytes. They have done like that. UTF-16 does not have variable length encoding, that's why it takes 2 bytes as a minimum value. Sorry, it takes 2 bytes. So that's why you will get the null value, that is 00. In null value, if you are using Windows applications, if you send the buffer, if it's taken as a string, then the input, the data after this null string gets truncated, because in every other languages this /0 is a null byte. You need to remember this one. If you are from C programming, you can just easily understand this. This null byte can identify as a string terminator. If I say AAA/0 and then if I type BCD, then the application takes only the input AAA 3 years, and it will ignore the input BCD because of this /0. This is like string terminator. That means the application reads from the input from left to right, and then upon seeing this /0, the application just ignores this BCD. That's what happens in the string applications. So that's why normally almost our modern applications have the Unicode encoding, because there are so many other different languages users using. That's why you need to make sure that the Unicode is there in the application. Then you need to exploit the Unicode buffer overflows according to the conversion of the bytes. So there are some Unicode pages, we will discuss about that in the buffer overflow section if the time permits. These Unicode buffer overflows are not necessary for OSCP or some any other certifications, but I just said that there will be this Unicode encoding, and if you suddenly see this, like some null bytes are coming or some other transformations are being occurring, then you don't need to worry. It's maybe the Unicode encoding. The mainly Windows and Java applications uses this UTF-16 encoding. So you need to deal with this UTF-16, and if time permits, I will add this Unicode buffer overflows also. So that's all about this character encoding, guys. I hope you have understood. We have discussed about the ASCII and the extended ASCII called ANSI, and then UTF encodings.